Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce and Management, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain BBA Aviation courses. Under that course, second semester, Mathematics for Management 2. Under that, unit number 2, Transportation Problems. Here, transportation problem, we talk about that source and designation, how it will be reaches from one place to another place, different sources to different designation with the shortest cost of the route. So this will shows that minimizing the transportation cost. This is also one of the problem of operation research model. This model will help us to make and reduce the cost of the transportation in one place to another place, different sources to different destination. In other ways, we can say supply and demand. Here we need to think about that it is a modification version of linear programming problem, but we will consider as a constraints are equal to 1. Transportation problem is a linear programming. Transportation problem is a special type of linear programming problem where the objective is to minimize the cost of distributing a product from a number of sources to a number of destination. The transportation problem deals with a special class of linear programming problems in which the objective is to transport a homogeneous product manufactured at several plants or origins to a number of different designations at a minimum cost. That's what I explained earlier. The total supply available at the origin and the total quantity demanded by the designations are given in the statement of problem. The cost of shipping a unit of goods from a known origin to a known destination also given. Our objective is to determine the optimal allocation that result in minimal total shipping cost. General mathematical model. Already we studied that LPP, graphical method, formulation of LPP. What is the method will be here? Here you see minimize the cost function and variable decision variables, and then your summation of the cost less than or equal to supply, and then summation of the another cost demand less than or equal to or greater than or equal to demand. So here we'll take both are equal in form. Supply and demand will be equal. Always xij, that is decision variables are greater than 0 for feasible solution to exit. It is necessary that total capacity equals to the total requirement. This only ways we need to set here. The problem is total supply equal to total demand. Suppose it is invariance, we need to make a balance. Unequal, we can make a equal in values. Summation ai equal to summation bi. If total supply equal to total demand, then it is a balanced transportation problem. There will be allocation of the cells m plus n minus 1 basic independent variables out of m into n. It's a matrix format will come m rows n columns. In that we are going to find out these values. Assumption in transportation problem. Here sum of or total of supply equal to total of demand. Only a single commodity is shipping from an origin to a destination. Total supply always is equal to total demand. Then only we can able to solve this problem. Otherwise, we cannot able to solve it. Suppose it is not equal, then make us to equal. There is a special case of transportation problem. There is an assumption you need to be follow. Supply and demand are positive integer. Here there is no question of negative values. Basic terminology will be used. What other words will be used for the transportation problem? Operation research, vocabulary with some new terms related to transportation problem in linear programming. Origin. It is a location from which shipments are dispatched. These are used in the transportation places in different destination. Destination. It is a location where in which shipments are transported. Unit transportation cost. One place to one supply to or one place to another place. What is the cost of the shipping will get here? It is a cost of transporting one unit of the consignment from origin to a destination. Permutations technique. It is a method used modifying a degenerate transportation problem so that the degeneration can be resolved. That is the meaning of total supply equal to total demand. When we are getting that, in that solution variables or cells will be in the form of m plus n minus 1 allocated cells that we are going to see in that. That means the values will be finding. That should be calculated. If it is not satisfied that condition, then we can say it is called degeneracy problem. In our syllabus, we are going to study only non-degeneracy problem. That is, the decision or allocated value cells of the values will be in the basis of m plus n minus 1 cells. Feasible solution. A solution that satisfies the row and column some restriction and also the non-negative restriction is a feasible solution. Satisfies the rows and columns of some restrictions. Basic feasible solution. A feasible solution m cross n transportation problem is said to be a basic feasible solution. The number of allocations equal to m plus n minus 1 cells. While solving, we will understand this. Optimal solution. A solution is said to be optimal when the transportation cost will be the minimum cost. As much as possible, we can make a minimum value. In this section, we will concentrate on algorithm for finding solutions of transportation problems. There are three methods. Initial, basic, feasible solution. Unfortunately, our syllabus also will talk about initial, basic, feasible solutions only. There are three methods. One is northwest corner, matrix minima, and Vogel approximation method. Apart from that, row minimum, column minimum method is there. That two methods are not required. We will study northwest corner rule. Then matrix minimum method. Matrix minimum will say in the least cost in other ways. Least cost method. Then third one is very important, Vogel's approximation method. We will write in the short form VAM method. VAM. All the words of first letter of Vogel's approximation method. These are the three methods what we have the syllabus. It is a basic feasible solution in a simple problems only is mentioned. So with this type of problem only we are going to study here. northwest corner. Whatever is showing in this top will be north will consider, left part will be west will be consider, right part will be east, then down part will be south. So this is the way we will consider as northwest corner. Now to solve the northwest corner. Northwest corner rule is a method for computing a basic feasible solution of transportation problem where the basic variables are selected from the northwest corner, that is top left corner. Usually we take in consideration of this method. The standard instruction for a transportation problem are faced below. Steps: select the upper left hand corner cell of the transportation table and allocate as many units as possible equal to the minimum between available supply and demand. That is mean row wise and column wise value you have to take. From that, how much is possible to allocate minimum value, both are common, should be considered. Adjust the supply and demand numbers in the respective rows and columns. Each row total should be same, each column should be same, should be considered. If demand for the first cell is satisfied, then move horizontally to the next cell if in the second column. If the supply for the first row is exhausted, then move down to the first cell in the second row. So what does that mean? Row is completely over, then go to the next row. First row is completely over, second row should go. Second row is over, third row. Similarly, column is over, second column. Second column is over, third column. Like that. That is the meaning of that. For any cell supply equals to demand, the next allocation can be made in a cell either in the next row or next column. Suppose equally is being allocated, then we have to go next row or next column. Continue the process until all supply and demand values are exhausted. The same procedure will be continued till all are balancedly and equally assigned. Now this is one of the problem. Amulya Milk Company has 3 plants located throughout a state with a production capacity 50, 75 and 25 gallons. Each day the firm must furnish its 4 retail shops R1, R2 and R3 or 4 with at least 20, 20, 50 and 60 gallons respectively. The transportation cost in are given below. Here is clearly mentioned milk product company has 3 plants. Plant 1, plant 2, plant 3. And then retail shop is 4. R1, R2, R3, R4. Here it is not a matter or it is not an issue of how many rows or how many columns. Here we need to check only supply equal to demand or demand equal to supply. Okay, demand values, demand row, you check it out, 20 plus 20 plus 50 plus 60. So totally will get 150. Similarly, supply also is getting RC 50 plus 75 plus 25. You will get 150. Both are equal. We can say it is a balanced transportation problem. We can able to solve it without any changes in the problem. The economic problem is to distribute the available product to different retail shops in such a way that the total transportation cost is minimum. Here you see demand and supply value should be placed in plant to retail shop with the minimum cost. All supply should be applicable, all demand also should be applicable. Which part, if you, which product plant, which retail staff, if you connect it, which is the minimum cost, this should be balanced. That is our question. Now the given values is given. Look at that again problem. Plant 1 It's going for the retail, one is 3 rupees. If you consider in rupees, okay. Plan 1 reaching to the R2, retail 2, that is 5 rupees. Plan 1 R3, 7 rupees. Plan 1 R4, 6. Similarly, plan 2 R1, 2 rupees. Plan 2 R2, 5 rupees. Plan 2 R3, 8 rupees. Plan 2 R4, 2 rupees. Plan 3 R1, 3 rupees. Plan 3 R2, 6 rupees. Plan 3 R3, 9 rupees. Plan 3 R4, 2 rupees. This is the cost of transportation. Moving the goods or vehicles charges is given. The demand and supply should meet with a minimum cost. That is our motive. Okay, look at this table. The cost will be written in the box, small box. There is a transportation from plant to retail shop. Now, what is this method is called as northwest corner method. Northwest means top left corner cell. Each box will consider as in a technical term is a cell. Each cell will be a row and columns only based. First row, second row, third row. Similarly, first column, second column, third column, fourth column. These are based on matrix concepts only we are applying. First, that is 3 is the cost. First row, first column. 5, first row, second column. 7, first row, third column. 6, first row, fourth column. Similarly, second row, first column, second row, second column, second row, third column, second row, fourth column will be considered. Now, we are going to how to solve this problem. We know very well, northwest corner means here top and left corner cell. That is, here cost will be, top will be 3. First row, 3, first column will be considered. Look at that, this is the supply will be given. 50 rupees, 75 rupees and 25. At the same time, demand also will be given 20, 20, 50. These two are given in the problem. We know very well this total will be balancing either row wise and column wise. 50 plus 75 plus 25, 150. Similarly, 20 plus 20 plus 50 plus 60 equal to 150. So first we need to check. Look at your top most corner, left corner. So here you see first cell, that is 1 1. First row, first column only will start. Row is completed, column will go. Column is completed, row will go. Here supply and demand I cancelled. You see that here both I will be cancelled. Here minimum is 20. Here 50 is there. So balance is 30 I return. So row wise and column wise 20 will be allocating. Where I am going to allocate? In the first row, first column cell. This is the way one. Here where is that? Over column values are over. Row value still is there. So column should be cancelled. Remaining cells, remaining boxes. Clear? This is the first procedure. Now column is over. Then we have to move to the second column. First column is over, second column we have to go. So next value. What is that here? The values here 30 and 20. That means first row 30 will be there, second column 20 will be there. So will be cut here. The remaining will be here 10. So that 10 will be allocated here. So remaining 10 is that the minimum value of 20 and 30 is 20. So 20 will be allocated here. So still row is available. How much is available? 10. But column, second column is completed. So will be cancelled. So we are not going to consider. Still first row is available. How much is available? 10. So for third column 50. So minimum is 10. Minimum we should be considered. So we will cut that. What is the remaining of in the third column? 40 will be remaining. How much I can allocate? 10 will be allocated. You need to check row and column that how much is the value. In that minimum value will be considered. Suppose it is maximum, remaining will be balancedly returned. Now you look at that. first row everything is completed. Then remaining one column is there that we can cancel. Then come to the second row, third column. Here 40 and 75, which is minimum 40. So 75 minus 40 will be deducted, 35 will get. So here I should be allocated is 40, where the cost of the, that is second row, third column. Now third column is completely over, so will be cancelled. Now second row is available. How much is available? 35. Then fourth column 60. In that minimum is 35. So 35 separated from 60 will get 25. So that 35 will be allocated second row, third column. Finally 25 is left out. That should be balanced. Always the final allocation we should get balanced. If we get balanced only, it is a correct solution. Otherwise it is not a correct solution. So we will get a 25 will be allocated. This is the way northwest corner rule will be applicable. Now this is the way everything is balanced without excess of any amount. Now we need to be allocated. Where are the places we allocated? First row, first column x11 20. First row, second column x12 20. First row, third column x13 10. Second row, third column 40. Second row, fourth column 35. Second row is over. Third row, third column will get 25. This is the way we can able to find out the problems which is getting here. Then the cost will be calculated. 20 into 3 plus 20 into 5, that corresponding the cost of the transportation we need to be considered. Then 10 into 7 plus 40 into 8 plus 35 into 2 plus 25 into 2. This will simplify. We will get 60 plus 100 plus 70 plus 320 plus 70 plus 15. This is the way we can calculate it. Total minimum cost is 670. According to that, the plant and retail shop will be reaching that value, will get as 670 rupees. That is the way we can able to minimize the transportation of the given set of problem. This is the way we can able to find out using the northwest corner method. It is another problem will be considered. 3 factory, 4 warehouses. Supply and demand is given. So first we need to check supply. Total supply equal to total demand. Supply value 30 plus 50 plus 20 100. Demand 20 plus 40 plus 30 plus 10 100. Both are balancing. So then we can able to solve it in this method. The similar procedure only we'll take it as considering is northwest corner rule. So will be written in the form of the cost will be transported one factory to warehouse. So demand and supply will be written in this form. So this is the way Leo will get it here. Now northwest corner rule means the topmost left corner value, that is first row first column. Here first row first column, what is the value? The row is 30, column is 20, which is the minimum? 20 is the minimum. So will be cancelled. The remaining 10 will be written here. So how much is allocated? First row first column 20 is allocated. Here first column completely over, so will be cancelled. Then come to first row second column. How much is the row is 10, column is 40. So how much is the minimum? 10 is the minimum. So will be cut. So remaining will be 30 will be there. How much I am going to allocate in first row second column? The cell is 10. Now row is some completely over, will be cancelled. Then what is that? Second row, first column over, second column is there. Here row wise is 50, column wise is 30. So minimum is 30. So cancel. remaining will be 20. How much you are allocated? 30. Now second column is completed. Then I will go to third column, second row. 20 and 30 is the value which is minimum. 20 is the minimum, balance is 10 I will be returned, then will be considered as your 20 will be allocated. Now second row completely over, then will be cancelled. Then come to third row, third column. What is that? 10 and 20. In that 10 is the minimum. Cut that. Remaining 10 will be returned here. Then allocated your 10. Then remaining balance is 10 only. So you can cancel and allocate. This is the way northwest corner rule will be applicable. Now we will remember that first row, first column, how much is allocated? 20. First row, second column, 10. Second row, second column, 30. Second row, third column, 20. All green I written in the within the box, that is the one. Third row, third column, 10. Third row, fourth column, 10. So the values are x11 20, x12 10, x22 30, x23 20, x33 10, x34 10. Then we'll find out with the cost, multiply with the transportation cost. 20 into 1, 10 into 2, 30 into 3, 20 into 2 plus 10 into 5, 10 into 9. So multiply 20 plus the 20 plus the 90 plus 40 plus 50 plus 90 equal to minimum cost is 310. This is the way the transportation problem try to minimize the cost. So finally we can minimize the cost is 310. This is the northwest corner rule method. This rule will applicable in this format only. Any kind of problem, any number of rows, any columns, we will get in this way. Now we are going to study matrix minimum method or least cost method. This method will show about that within the table what is the minimum value that we can be calculated. Matrix minimum or least cost method is a method for computing basic feasible solution of a transportation problem, where the basic feasible or basic variables are chosen according to unit cost of production. This method is very useful because it reduces the computation and the time required to determine the optimal solution. This is also one of the method will use comparatively northwest corner. This will help. Steps will be followed when you are using the matrix minimum or least cost method. Identify the box having the minimum unit transportation cost within the box. If the minimum cost is not unique, if they are, you are liberated to choose any cell. That means more than one value if you are getting, then you can choose as a liberty. Choose the values of the corresponding x values as much as possible subject to the capacity and requirement of constraints. Repeat step 1 to 3 until all restrictions are satisfied. This is a procedure to follow least cost method. So this is another problem. Problem will be the same type like transportation problem, but here we need to understand that the cost will be taken factory, retail, shop. So values are taken and will be considered. Here matrix minimum how we are going to consider. So we will be writing in this format, least cost method or matrix minimum method. This is a way we can find out. Then supply will be written and then demand will be written. This is a complete setup. Here within that, within the box I written cost. That is unit cost will say. That is cost of transportation one destination to that destination. Your factory 1, 2, 3 or plant 1, 2, 3 or retail shops 1, 2, 3, 4. Okay. This is the one cost. Here I given the colors because repetitions are there. Unit cost same is there. Will given as a colors. Remaining or different is a red is given. Here you see 2 will be repeated thrice, 3 will be repeated twice, 5 will be repeated twice, and 6 also repeated twice. Why we are considering here unit cost means the problem is matrix minimum. Matrix in the sense in the table, what is the values, minimum value need to be considered. That is called matrix minimum, will say. At the same time, we need to consider least cost. Cost in the sense unit transportation cost. Within that least cost, first least cost means 3 places are there. That is 222. Green color I mentioned, no, that is 222. Here we need to how to select it to which two we have to be selected. Here we check second row and third row is there too. Second row first column, second row fourth column, third row fourth column. In that, which is the minimum cost, minimum value can be allocated in the particular cell. Here 20, 75, 20 will be allocated. So here second row fourth column you see 75 and 60 is there, so will be allocated 60. And then third row fourth column 25 and 60 is there. Row to value supply and demand is checked. In that which is the minimum, 20 and 75, 20 is the minimum, so we can allocate it as 20. Look at that, remaining more than 20 will be allocated. Second row fourth value 60 should be allocated. Third row fourth value 75 will be allocated. Second row first value will be only 20 will be allocated. That will be considered. Look at that, cancelled. Remaining will be 55. Allocated will be 20. This is the one. Why I selected here? Comparatively other twos, here minimum value, because our problem says minimum cost. Transportation cost will be considered. So we will be considered as 20 only here. You got it? Why I selected here? Because of the remaining places, one place 60, another place 25. In this place only we will get 20. So minimum comparatively other three. So we will be considered remaining first column completely over. So we will be cancelled down. Come to the next one. Again 2 is a least cost. Empty cells is a no, filled one, leave it. Remaining you check it out which is the least. 2 is the least. 2 located in 2 places. So first one is we 55 and 60. 55 will be allocated. Third row fourth one is fourth column is 25 and 60. 25 will be allocated. So we will be consider third row fourth column. So consider here where is the minimum, column wise minimum will be written. Here how much is the minimum value? 25. 25 will be allocated. Left out is 35. So here completely the third row will be over. So all the value will be cancelled. Okay, next to empty cells which is a minimum 2 again. Here how much you can allocate? 55 and 35. In that minimum is 35. So balance will be written here. So how much will be allocated? 35 will be allocated. Now fourth column completely over will be cancelled. Then out of that 5, 7, 5, 8 is there, empty cells. In that minimum is 5. There are 2 5s is there. In that first row, second column, you check it out. In that 2 is there, 5, 5. Second row 20, 20 equally is there. But first row 50 value remaining. Second column is 20. So here 20. But here minimum value both the places 20, 20 only we can allocate. We can choose our own cell. It is not a matter because both are equal. Then we can take down 20, 20 equally is there. So will be cancelled. Here both unit cost also same, both values are also same. Then we can choose by our own. So 20 will be selected. Here second column completely over. So cancelled. Now it's left out only third column. There are 2 cells 7 and 8. In that minimum is how much? 50. So will be considered as 50. This is the column is over. Then 50 equally will be cancelled. Likewise equally we need to cancel Here what is that? Matrix minimum. In that table, unit cost of transportation which is minimum, that should be considered according to the procedure. Now the solution will be right. First row third column 50, second row first column will be allocated 20, second row second column allocated 20, second row fourth column allocated 35, and then third row fourth column 25. You need to see that given values in the problem and allocated values both row wise and column wise must and should all be tallied. The total if you added will get equal. Now transportation cost, that cost will be multiplied 50 into 7, 20 into 2, 20 into 5, 30 into 2, 25 into 2. Then cost will be 350 plus 40 plus 100 plus 70 plus 20. The complete box transportation cost and allocated value both will be calculated and get the value 610. This is the way matrix minimum or least cost method will be calculated. Will be consider another one problem. Here also another one problem, warehouses and factories will be considered. Here you see supply and total will be calculated here 450 exactly is getting. So in this way only we are going to send it. That is the one we are given in the syllabus. So will be consider matrix minimum. This box will be given that unit transportation cost will be returned. Then supply 200, 160, 90. Here demand will be considered 180, 120, 150. So we know total supply equal to total demand. Both the sides we added, we got it clean. Then here minimum matrix value or matrix minimum value or least cost method. In this table, what is the least cost here? 8 will be the least cost. Second row, second column. So that row total supply is 160, here 120. Which is minimum? 120 is the minimum, will be cut. Then remaining will be, what is that? 40 will be remaining in the second row. How much will be allocated here? 120. In that second column completely over will be cancelled. This is the way we need to follow. See that row, that column which is minimum, that should be allocated. Where is the extra is that will be returned as it is. Now second column completely over. First column and third column you check it out which is minimum there. It is I think it is 12 is the minimum cost. So there will be 200 and 150. How much you can allocate? 150. So remaining 50 will be returned. So allocate 150. So third column completely over will be cancelled. Come to the first column. What is the minimum? 14 is the minimum. In that row 40 is there, column 180 is there. In that which is minimum? 40 is the minimum. So how much you will allocate? 40. Remaining balance will be returned 140. So 40 will be allocated. That value should be allocated. Then next one is 16 is the minimum. 16 row will be 50 is there, column will be 140, which is how much we will need to allocate? 50 will be allocated. Cancelled. The remaining will be returned. So allocation is 50. Then finally only one cell is there, row wise 90 is there, column wise also 90 is there. So both are being tallied, then we will get that 90. This is the way we need to be calculated. Both the way we need to be balanced, then only we will get equal values. Otherwise we cannot able to get it. This is the way we need to follow. Then we write the solution. x1 150, x13 150, x2 140, x22 120, x31 90. Then the cost will be calculated 50 into 16 plus 150 into 12 plus 40 into 14, 120 into 8 plus 90 into 26. Then simplify 800 plus 1800 plus 560 plus 960 plus 2340. Total is 460. So this is the way you need to be calculated. Check with the calculation. Any corrections are there, anything is there, please go through the concept and get the values correctly. Okay. This is a second method. Now I'm going to explain third method. This is a very important method of solving best feasible solution. Okay, initial feasible solution. There are three types. This is third type we are going to study. Vogel's approximation method, or we can say penalty method, unit cost penalty method, is an iterative procedure for computing basic feasible solutions of transportation problem. This is very important problem.